Okay, so today's lesson is about multiplying and dividing monomials. So does anybody know what the prefix mono means? M-O-N-O. Okay. It means one. One. So when we're looking at monomials, we're going to be looking at a single term. One term. It says, for each increase on the Richter scale, an earthquake's vibrations or seismic waves are 10 times greater. So an earthquake of magnitude 4 has seismic waves that are 10 times greater than a magnitude 3 earthquake. It says, examine the exponents of the powers in the last column. What do you observe? So we look here at our Richter scale. So a Richter scale, a category 4 earthquake is 10 times greater than a category 3 earthquake. Now, if I was on the Richter scale for 5, that means it's 10 times 10 greater than a magnitude 3, which is 100. Another way we could write that is 10 to the second, right? 10 to the first times 10 to the first is 10 to the second. What about this? If I had a 6, that's 10 times 100, or 10 to the first times 10 to the second, which is 10 to the third. A magnitude 7 is 10 to the first times 10 to the third, which is 10 to the fourth. And a magnitude 8 is 10 to the first times 10 to the fourth, which is 10 to the fifth. Now look at the exponents of the powers in the last column. What do you observe? So do you see some kind of pattern that's happening there on the last column? Yeah, what's adding 1? The exponent, right? The power is increasing by 1 every time. From 10 to the second to the third to the fourth. So now, write a rule for determining the exponent of the product when you multiply 2 powers with the same base. Test your rule by multiplying 2 to the second and 2 to the fourth using a calculator. So don't use a calculator right now, but think, if you were multiplying 2 to the second times 2 to the fourth, what do we think our answer would be? Using these same rules that are happening here. Okay, and how did you get 2 to the sixth? Yes. So when we multiplied powers that have the same base, like you see, here's a base of 10, and here's a base of 10. When we look up here, 10 to the first times 10 to the fourth, we're multiplying powers that have the same base. They both have a base of 10. We keep that base the same, and we add the exponents. First plus fourth gives fifth. So right here, we're multiplying 2 powers. 2 to the second and 2 to the fourth. They both have a base of 2. So we keep the base the same and we add the exponents. So 2 to the second times 2 to the fourth is 2 to the sixth. Say I was given this problem. 2 to the third times 2 to the fourth. What does 2 to the third power mean? Well, that means we're doing 2 times 2 times 2. Right? You're multiplying the number 2 3 times. Now what does 2 to the fourth mean? We're multiplying the number 2 4 times. So if I multiplied 2 to the third times 2 to the fourth, what am I really getting? I've got now 1, 2, 3, 4, 5, 6, 7 2's. So it is the same thing as 2 to the 7th power. You see how we're just adding those exponents to get there? Everybody understands how we're doing this? Okay? It's very important because we're going to start using numbers that have variables in them, right? So the only way you can do it is to use this rule for multiplying powers. Okay, so it tells me to find 7 to the third power times 7. So I'll let you write that down. 7 to the third times 7. So the first number here, that's a power. Is this a power? No, it doesn't have an exponent. Well, can I write an exponent with it if I wanted to?
Yes.
I could. I could write the first power. Okay? Any number without an exponent can be written to the first power. So now I'm multiplying powers. Do they have the same base? 7 and 7. Yes, they have the same base. So we keep that base the same. And then we want to add the exponents. So that would give us 3 plus 1, which is the fourth power. So 7 to the third times 7 is 7 to the fourth power. And again, we can think about it by what do exponents actually mean? Well, 7 to the third is 7 times 7 times 7, and then we want to multiply that by 7. So now I'm multiplying 4 sevens. That's how we get 7 to the fourth power. Okay, try these two. Okay, what'd you get for A?
5 sevens.
5 to the seventh power, 5 to the seventh. If you say 5 sevenths, that's a fraction. Okay, that is correct. Any questions on A? Pick a number 1 through 6.
It's 6.
Pick a number 1 through 2.
The answer is 2.
Okay, what did we get on B?
I got 1/2 to the 11th.
1/2 to the 11th power. That is correct. Okay, just because it's a fraction, it doesn't get any more challenging. The one thing I will tell you about a fraction to be careful about, if you just write it like this, okay, that could just mean 1 is raised to the 11th power, not the whole thing. So in order to make sure that we're knowing the whole fraction is being raised to the 11th power, we probably want to put that in parentheses. It's a number, variable, or product. What is a product? Answer to a multiplication problem, right? So a monomial is a number, variable, or a product of a number and one or more variables. Monomials can also be multiplied using the rule for the product of powers. So we're going to be using these rules that we just came up with for multiplying exponents on monomials. All a monomial is, it does not have a plus sign in between two terms. Like 6 plus 7, that has two terms. Okay? It would have to be something like 3 would be a monomial, or 3x would be a monomial, because that's a product. It's a number and a variable being multiplied together. Okay, so here's our first problem. You may want to write it down so you have these notes to look back at. X to the 5th times x to the 2nd. So both of these are monomials because there's no plus sign in between them. Do these have the same base? Yes, they both have a base of x. So we keep the base the same and we add the exponents. 5 plus 2, which would give us 7. So x to the 5th times x to the 2nd is x to the 7th power. Okay, write this one down. Negative 4 n to the 3rd times 2 n to the 6th. Are these monomials? Yes, this is a monomial and this is a monomial. So we're going to multiply them. Now, this third power, it only goes with the n. This is not negative 4 to the third power. Only the n is raised to the third power. And the same thing here. Only the n is raised to the 6th power. It does not go with the 2. Okay, so the first thing we're multiplying, negative 4 times 2. Are those powers? Do they have the same base? No, that's just regular number multiplication. So you can put that in your calculator or do it in your head. Negative 4 times 2 is negative 8. So I have multiplied the negative 4 times 2. Now what is left? I have an n to the third times n to the sixth. Are those powers?
Yes.
Do they have the same base? Yes. So we keep the base the same and add the exponents. 3 plus 6 is 9. So negative 4 n to the third times 2 n to the sixth is negative 8 n to the ninth. Okay, what'd you get on C?
On C, I got 24 M. That's that out.
24m to the fourth power? What do y'all think?
Yes, I am. Yeah, because you have to. Oh, get that. I forgot if one didn't have a.
Okay.
You had to add one.
Correct. So since this m did not have an exponent, we could think of that as being m to the first power. So we're multiplying m to the first times m to the fourth. That should be m to the fifth. So 24m to the fifth would be the correct answer there. Any questions on C? Yep. Okay, let's look at D. Pick a number 1 through 6.
That would be 3.
Pick a number 1 through 2.
It's 1.
Okay, so this one is definitely the hardest one we've done so far. So let's take it one piece at a time. So right here I have a 5 to the second. Does it have anything like it in the other monomial?
Yeah.
Yeah, 5 to the third. Are those powers?
Yes.
Do they have the same base?
Yes.
So what do we do when we multiply powers with the same base?
Keep the base and then you add the.
Keep the base the same and we add the exponents. So 5 to the second times 5 to the third should be 5 to the fifth power. Now we look at the next one. I've got an x to the second. Is there anything like x to the second? There's an x here. Does it have an exponent?
No.
Can I give it one?
Yes.
You can give it a 1. So now what is x to the second times x to the first?
Next to the third.
That's going to be x to the third. And then I've got y to the fourth. Is there anything like that?
Yes.
Y to the third.
The 7.
Keep the base the same. Add the exponents. So this should be 5 to the fifth, x to the third, y to the seventh.
Oh, we can have stuff like that on like this.
Yes.
Oh my gosh. That's not hard. That's really easy.
I got 5x12.
Y'all are getting 14 because you're just adding all these exponents. 4 plus 2 is 6, plus 2 is 8, plus 3 is 11, plus 3 is 14. You can't add the exponents unless they have the same base. That's why you have to do it a piece at a time. The 5's have the same base. The x's have the same base. The y's have the same base. Then you can't combine them. So like, good question. We got to ask, what if they were different? So what if you're multiplying this? 5x to the third times 3y to the seventh. Okay, write this one down. This will be our next problem. 5, is that a power?
Yeah. No.
Okay, so this 5 is not a power. I could give it an exponent, and I could make it 5 to the first if I wanted to. If I did, would this number have the same base? No. So 5 and 3, it doesn't make any sense to multiply them like powers. So just multiply them as numbers. What is 5 times 3? 15. So I multiplied this times this. Now I'm looking, x to the third. Is there anything like x to the third in the other monomial? No, there's not. This is an x. There's nothing with an x in the other monomial. So x to the third would stay x to the third. Now, is there anything like y to the seventh? No. So it would stay as y to the seventh. So if I multiplied those two monomials, my answer would be 15 x to the third y to the seventh.